Paper of the day is HYRISE, a main memory hybrid storage engine. It's a 2011 paper. This paper presents HYRISE, a main memory hybrid database system designed to maximize the cache performance of queries. HYRISE creates vertical partitions of tables of different widths depending on the access patterns of queries over table. To determine the best partitioning, they developed an accurate model of cache misses that is able to estimate the number of misses that a particular partitioning and access pattern will incur. They presented a database design algorithm based on this model that finds partitionings that minimize the number of cache misses for a given workload, and that is able to scale to tables with a large number of columns. The results show that HYRISE is able to produce designs that are 20 to 400% faster than either a pure column or pure row approach on a realistic benchmark derived from a widely used enterprise application. Looking at the benchmark, most database benchmarks are built to address a specific market, that is OLAP or OLTP. For example, the TPCC is an OLTP benchmark and TPCH is an OLAP benchmark. Creating a hybrid of TPCC and TPCH is difficult since each benchmark uses different schemas and workloads. Consequently, they chose to create a new workload derived from a real database application. To evaluate their model, they chose a set of queries derived from a SAP Enterprise Resource Planning application that includes several analytical queries that model reporting over recent history of these transactions. To show the robustness of their approach, they execute one analytical query in two different versions with a layout-dependent selectivity of 2% and 50%. Coming to contributions, key contributions of this paper are: first, they develop a detailed cache performance model for layout-dependent costs in hybrid main memory databases. Second, they develop an automated database design tool that, given a schema, a query workload, and using their analytical model, recommends an optimal hybrid partitioning. Third, they show that their system running on a customer-derived benchmark is 20% to 400% faster than either a pure row or a pure column stored running on the same data. They also show that their designs are better than previous hybrid storage schemes. Now let's give this paper a PS score. Overall, it's very bumpy read, so it gets 5 out of 10 on readability. With 12 pages long, it scores 8 out of 10 on length. Reproducibility will be challenging, so it gets 6 out of 10. Industry value is not proven, and I'm not aware of any commercial systems that have adopted HYRISE approach, so it gets 5 out of 10. Learning is decent, so it gets 7 out of 10. Overall PS score is 6 out of 10.